Okay.
Next, you want to draw the layout diagram direct to the PCB. This is a single side PCB. One side is Highland sheet, the other side is copper coated. You are taking one piece of the PCB and remove the dust and all using some steel wool. Simply clean the PCB using steel wool. That time you can see the exact covering of the copper on the board. You can see, say, plain copper. And what are the points you need? First of all, we want to connect the step down value to the concerned PCB. So we are marked 3 points. This way. The bubbling means while you want to drilling on the center of the point. When we are marking the points, it will be remain copper. So the component's lead is placed on the center of the points. Okay. This way we want to connect the input points. Next we want to connect the D1. The anode should be connected on this point and using this 1N4001 for rectification, and we are placing on the top side of the board. The component is placing on the top side. So the D1 consists of this much length, and this lead should be we are bended and placing on the top side. So the body of the D1 must be only very small space. So we are providing that space for placing the D1, and the cathode should be connected this point, and the common line should be extended. Okay, and the D2 should be placed across the common line and top line. Across the center line we are placing the D2 because of the compound is placing on the top side, and we are making the holes on the bottom side. And next thing is you want to place the filter capacitor. The filter capacitor size is this much space. The size of the 330 microfarad is this much, and we can place the component on the top side. So its total space is this much space is required. So for placing the filter capacitor we are making 2 points. And next one is a series resistance. For resistance we are providing this much space. And next thing is we want to place a Zener diode across the ground line, and the next we want to connect the outputs, making 2 points for taking the output from board. So simply we are drawing the layout diagram to the PCB using permanent marker. You can mark the points how much thickness you need. That way we are mark all points, and this way neatly you can draw the layout diagram using scale and marker pen. and afterwards the PCB is going for the etching process. The etching means the removing of unwanted copper from the board. That is the process of etching. The ferric chloride solution is used for etching. While putting into the ferric chloride solution, the copper will be dissolved on the ferric chloride solution. That means where you are marked, that portion remains on the board. All other portions are dissolved in the ferric chloride solution. That process is called etching. And after etching, you will get this type of board. Okay, this way only the remaining marked portion should be remaining on the board. The other copper should be dissolved on the ferric chloride solution. Afterwards, wherever you require the components leads to be placed, we are drilling that point using the drilling machine. Okay, and you can see this side the holes are visible. On the bubble center we are marking drilling the points, and next you want to place the components. Step, you want to place the D1 from the top side. The anode should be coming this point, and next point we are placing the cathode. Okay, and this way you can mount all other components and solder it using the soldering iron and give the input. That means the step down value 909 should be connected here. We can observe the output using multimeter or CRO. We will get 6 volt output on the output section. Okay, and each and every component should be placed from the top side. One by one you can place it, solder it, and take the output from the concerned point. Okay, things you want to write on the record. You can write the experiment number 6, design and fabrication single side PCB. Write the aim of the experiment. You can draw the figure of the fixed voltage power supply on the left side, and also you want to draw the layout diagram that should be shown on the board. That way you must draw the layout diagram on your record, and what are the steps for the fabrication PCB that should be explained on your record, and you can directly write the result. The result is you can design and fabricated a single side PCB and observe the output as 6 volt. Okay.